Friend, how are you? Hope all of you are fine. Student, I, Dr. Shefali Jain, Assistant Professor at Thankar Mahavir University. Student, today we discuss about Block 4 topic ISO Quant. What is ISO Quant? Prediction function with two variables, inputs or equal product curves. Prediction is the function of inputs is the functional relationship of inputs and outputs. So, according to Ferguson, an isoquant is a curve showing all possible combination of inputs physically capable of producing a given level of output. The terms in these the terms isoquant broken down in the Latin means equal quantity, as you also see in the definition. Isoquant means equal quantity with ISO meaning equal and point means quantity. Essentially, the curve represents a consistent amount of output. As I also written in this definition, capable of producing a given level of output. It means amount of output. The isoquant is known alternatively and as an equal product curve or a production indifference curve. Isoquant represent all those combination just like a indifference curve. I have also explained about the indifference curve in the previous video. And isoquant represent all those combination of inputs which are capable of producing the same level of output. So an isoquant is also known as production and indifference curve. So an isoquant show combination of two factors, capitals or labor. And the technological trade-off between the two, how much capital would be required to replace a unit of labor at a certain production point to generate the same output. And labor is often placed along the x-axis and ISO of the ISO quant graph and capital along the y-axis. I will also explain it in the further in the video. Also written again according to Ferguson. I have also written here, but it's also again an isoquant is a curve showing all possible combination of inputs physically capable of producing a given level of output. And in the words of Peterson, an isoquant curve may be defined as a curve showing the possible combination of two variables factors that can be that, that can be the terms isoquant and the I or ISO product is composed of ISO. So isoquant show the different combination of variable factors that gives the same level of production. And the terms isoquant or iso product is a composed of iso implying equal. I have also seen say the ISO is taken with the Greek word equal, and equal implying quantity or product or output. Thus, it means equal quantity or equal output. Difference factor are needed to produce goods. ISO curve are also known as equal product or ISO product or production indifference curve. Isoquant indifference curve is used for the consumer and isoquant is used for the production function. So we can say that isoquant are called the equal product or ISO product curve. Again, as all the combination yield the same level of output, the producer tend to be indifference among them. So, ISO point are also known as producer indifference curve. Now, we what's the assumptions for the ISO curve? The mean assumption of ISO point curves are as follows. First of all, two factors of prediction. Only two factors of production are used to produce a commodity because we have only two axes, x-axis and y-axis. So we can take only two factors, and these two factors are, one is capital and other is labor. Next, divisible factors. Factors of production can be divided into small parts so that one factor give up and other factor can be increased. So it should be divisible factors. Next, constant techniques. Techniques of production is constant or is known beforehand. The technique should be constant. Next, possibility of technical substitutions. The substitution between the two factor is technically possible. If the producer is ready to give up the capital, he can increase the units of the labor. So it should be technically possible. That is producer function of variable proportion types rather than fixed proportion. So next, efficient combination. Under the given techniques, factors of production can be used with maximum efficiency. Maximum efficiency, the producer should be uh, skilled person, and he can get a good combination, and get a maximum level of satisfaction, and he can get a good combination between two factors, labor and capital, and also get the same level of production. So ISO point has all these assumptions. So ISO point, it is clear with the assumption there are only two factors, two inputs, yeah, factors, labor and capital. Labor is symboli represent L, and capital is symboli represent K to produce a commodity X. And labor and capital can be substitute for each other up to a certain limit at a diminishing rate of substitution. I think you have understood what is the assumptions of the ISO point. Now, now we explain ISO product schedule. Let us suppose there are two factors, inputs, labor and capitals. And ISO product schedule show the different combination of these two inputs that give the same level of output as shown in the table first. Combination A. Units of labor used 1 and capital units of capital is used 15, and using both units, both factors, the producer get output of close 200 meters. Now in the second combination, the producer give up labor and increase the units of, sorry, give up capital and increase the number units of labor, and he use 2 labor and he give up 4 capitals 11. Now he use 11 capital. Now he also get output of close 200 meters. Now in the third combination C, he use units of labor 3 and he use units of capital only 8. Now he also get the output of close 200 meters. Now on the combination D, he also use unit of labor 4 and unit of capital use 6. Now he get output of close meter 200 meters. Now at the E combination, he also use unit of labor 5 and unit of capital is also 5. Now he get output of the close 200 meters. So you see that it is quite clear from the above table that different inputs combination point A, B, C, D, E yield the same level of output 200 meters. Thus, an ISO point should pass through these points. And moreover, can be seen from these combinations that both inputs are substitute for one another. Now we see here the table. You can also see table 1 shows the 5 combination of labor unit and unit of capital yield the same level of output 200 meters of clothes. Thus 200 meters clothes can be produced by combining first R point, 1 unit of labor and 15 units of capital. You can see it in the graph. On the x-axis, we take labor and on the y-axis, we take capital. As you see in the figure uh, at the A point, the producer used 1 unit of labor and 15 units of capital. You can see here on the x-axis labor, on the x-axis we took the labor and on the y-axis we took the capital and on the x-axis the producer took 1 unit labor and 15 units capital at the A point. Now he got 200 200 outputs. B axis, sorry, B point, the producer took 2 units labor and 11 units capital, and he got 200 meters outputs, close outputs. And on the C point, the producer took 3 units labor. You see here, 3 units labor and only 8 units capitals. And he also got same level of production 2 meter close. And the D unit, the producer take 4 units labor and 6 unit capital. You see here 6 unit capital, and he also got same level of produce output 200 meter. At the E point, the producer use 5 unit labor and 5 unit capital, and he got 200 meters production. So it represented above the IQ1 yielded the same level of output 200 units, 200 meters output close of X using different combination of L and K. But so uh, I think you have understood what is the ISO quant. Now, ISO product curve. uh, from the above schedule, ISO product curve can be drawn with the help of a diagram. An equal product curve represent all those combination of two inputs which are capable of producing the same level of output. I have also explained it before. In the figure 1 shows the various combination of labor and capital which give the same amount of output A, B, C, D, E and A, B, C, D, E. Okay, now I discuss about the marginal rate of technical substitution MRTS. The marginal rate of technical substitution is the number of units of labor that must be sacrificed in order to increase capital by 1 unit to get the same total output. It is also called the marginal rate of factor substitution. When the producer give up one unit, give up some units of the one factors and he increased the other factor. It is also called when he sacrifice one factors units to increase other factors unit. So and he also get the same total output. So it is also called the marginal rate of factor substitution. So the slope of the isoquant or marginal rate of technical substitutions on the graph show the rate at which a given, you see also here, at which a given input, either labor or capital, can be substituted for the other while keeping the same output level. The marginal rate of technical substitution is represented by the absolute value of n isoquant slope as a chosen point. You see also here in the schedule. It is the formula marginal rate of technical substitutions is a delta lever divided by delta capital. Now, an image of the formula of marginal rate of substitution, a table also showing here. You can see a combination, capital is 1 and lever is 10. And B combination, the producer sacrifice labor and increase the capital. He sacrifice labor from, you see here, from. And which he sacrifice, you put up, and which he gave, you put uh, down. So he sacrificed the labor 5 and he increased the capital only 1. So 5 upon 1, only marginal rate of substitution here is only 5. Now, on the C combination, you see here, because when we increase the when we increase any one factor's units, its marginal rate also decrease. Uh, so we are ready to give up less units of labor. Now the producer ready only give up sacrifice 3 units of labor and he gets 1 unit of capital. So the margin rate of substitution 3. So when we also increase 1 units, the marginal rate of substitution, marginal utility also decrease. So the producer now ready to give up less units of labor. Now he ready only 1 units of labor. He sacrificed only 1 unit of labor and increase 1 unit of capital. Now the marginal rate of substitution only 1. You are also see here in this graph, on the x-axis we put capital and on the y-axis we put labor. Here you see on the A combination, the producer uses 1 capital and 10 units labor and he give up 5 labor and increase 1 capital. So you see here it is the marginal rate of substitution. On the B point, the producer increase 2 capital and sacrifice 3 labor. It is the marginal rate of substitution B combination. And on the C combination, A, B and C combination, the producer use 3 capital and 2 labor. It is the marginal rate of substitution. It's shown. And on the T combination, the producer use 4 capital, only 1 labor. So it is the T marginal rate of substitution. And he got the prediction 500. So I think you have to understood what is the marginal rate of substitution. Question is here, why is marginal rate of technical substitution decreasing as we move along the same isoquant curve from one point to another? The total output remain constant. Here, hence the output gained from using 1 unit of capital must be equal to the output lost from using some unit of labor. So MRS, marginal rate of technical substitution, is decreasing because of the law of diminishing marginal returns. As a decline in marginal rate of technical substitution along an ISO point for producing the same level of output is called the diminishing marginal rate of substitution, as you also see in the figure. Now, from point A to point B, marginal rate of technical substitution 5. You see here 5. It is 5, and which means 5 units of labor must be sacrificed to increase capital by 1 unit in order to keep the output the same. Next, the output of 1 unit of capital is equal to output 5 unit of capital. I think, sorry, 5 unit of labor. ये sorry, misprint हो गया. So capital is of higher value because it's lower quantities, and the labor is less productive because of its sorry यहाँ पे because the producer have to give up its higher quantities. Now, from point C to point D, marginal rate of technical substitution 1C above the table, which means 1 unit of labor must be sacrificed to the increasing capital by 1 unit in order to keep the output the same. The output of 1 unit of capital is equal to the output 1 unit of the capital. So capital has become less productive with an increase in its quantity according to the law of diminishing marginal returns, because the producer have to sacrifice now less sacrifice of the labor to get another units of capital. So when we increase uh, one factors units, we also ready to decrease less units of the other factor. It's due to the diminishing marginal utility. So capital has become less productive with an increase in its quantity according to the law of diminishing marginal returns, and labor is now more productive because of its reduced quantity. The value of or output of 1 unit of capital decrease with an increase in its quantity. So the initial units of capital have a higher value as compared to the latter units. This is according to the law of diminishing marginal returns. In the marginal in the diminishing law of diminishing marginal returns, जैसे कि मैं आपको पहले भी बता चुकी हूँ, जैसे जैसे हम एक किसी भी कमोडिटी की एक से ज्यादा यूनिट्स इंक्रीज करते रहते, जैसे जैसे हम बढ़ाते रहते हैं, हमें जो उससे मिलने वाला जो सेटिस्फेक्शन है वो डाउन होता रहता है, मार्जिनल यूटिलिटी जो है डाउन होती रहती है. इट्स ड्यू टू द लॉ ऑफ डिमिनिशिंग मार्जिनल यूटिलिटी. Marginal MRTS is the slope or gradient of an ISO point curve. The slope MRTS shows the rate at which the labor and capital can be substituted. Diminishing marginal rate MRTS is the reason an ISO point curve is convex to the origin. Hope you have to understood what is the MRTS, marginal rate of technical substitution. Now we discuss about the ISO product map or equal product map. An ISO product map shows a set of ISO product curves. They are just like contour lines which show the different level of output. A higher ISO product curve represents a higher level of outputs, which is shown in the figure 2. We have family ISO product curves, and each representing a particular level of output. It means the ISO map as the collection of ISO curves in a single diagram. It means that an ISO curve map is a set of ISO points collected in a single diagram. It represents different production plants that the producer plan to produce. The ISO product map looks like the indifference of consumer behavior analysis. Each indifference curve represents particular level of satisfaction, which cannot be quantified. A higher indifference curve, it is qualified, not a quantified, because in the ordinal approach, we can only give the rank, and in the cardinal approach, we can measure the utility. But it's come in the ordinal approach. A higher indifference curve represent a higher level of satisfaction, but we can't see why how much satisfaction is more or less. Satisfaction or utility cannot be measured. Now you see in it an ISO curve on the other hand represent a particular level of output. The level of output being a physical magnitude of um, measurable. We can therefore know the distance between the two equal product curves. The ISO product curves are the units of output. They represent 100 meters, 200 meters, and 400 meter, so on. So ISO curve map as the collection of ISO point curve in a single diagram as you see here. So I already mentioned that a higher ISO point it is. Higher ISO point show a higher level of output as is consist of the more quantities of inputs. You see here it has more quantities of inputs, and the ISO point curve far from the origin. It is the key. It is far from the origin. It known as the higher ISO point curve, and the near this is one IQ one ISO point one near and the origin is known as the lower ISO point curve. It is called lower ISO point curve. It can be shown in the following diagram. You see here the above diagram. This diagram show an ISO point curve map. Are there are different ISO point curves represent IQ1, IQ2, IQ3, and IQ4. And IQ1 is the lowest isoquant curve. It presents the lowest level, only 100 meters, lowest level of output. And IQ4 is the highest isoquant and represent the highest level of output, yani 400. The highest isoquant IQ4 include more units of both labor and capital than that of the lower isoquant IQ1. Student, hope you understood well what is the isoquant map. We discuss about the properties of isoquant. There are several properties of isoquant. First of all, and it's also say the characteristics of the isoquant. First of all, iso predict curve slope downward from left to right. Left to right. They slope downward because marginal rate of technical substitution MRTS of labor सॉरी इसमें थोड़ा मिसप्रिंट हो गया है ये MTS हो गया of labor for capital diminishes when we increase labor we have to decrease capital to produce a given level of output. In the figure show, when the amount of labor is increased from OL to OL1, the amount of capital has to be decreased from OK to OK1. The isoquant curve is falling as shown in the figure. This means same level of production only occurs when increasing units of inputs are offset with lesser units of another inputs. This property falls in line with the principle of marginal rate of technical substitution uh, as I have also understood about it Now, next, you also see here the possibilities of horizontal, vertical, upward sloping curves can be ruled out with the help of the following figures. You see here, first of all, this show this figure. The figure A show that the amounts of the both factor of reduction are increased. You see here OK and OL. Now the producer increase OK to OK1 and labor increase OL to OL1. So labor from L to L1 and capital K to K1. When the amounts of both factor increases, the output must increase. Hence, the IQ curve cannot be slopes upward from left to right. Um, in this figure, the ISO point not left to right, downward left to right, but it will be outward left to right in this case. Now, in the figure B, shows the amount of labor is kept constant. You see here, while the amount of capital is increase, capital of increase. The amount of capital increase from K to K1, then the output must increase. So ISO point cannot be vertical straight line. Vertical straight line, this is not the figure of ISO point. Now the figure C show a horizontal curve. If it is horizontal, the quantities of labor increases, although the quantity of capital remain constant. Here the one factor is remain constant. When the amount of capital is increased, the level of output must increase. Thus, an ISO point cannot be horizontal line. It is never showing in these conditions. Now, next step, ISO can point are convex to the origin. This is show this thus you see convex. It is convex, not concave. Convex left to right downward. It may be observed that due to falling marginal rate of substitutions, ISO marginal rate of technical substitution, ISO always convex to the origin. This indicates that factors of reduction may be substituted with one another. The increase in one factor, however, must still be used to conjunction with the decrease to the another output. Now, next ISO higher ISO product curves represent higher level of output. This is because of the fact that higher curve will either have more units of one factors of both. You see here on the first ISO point, the producer use OK uh, capital and OL labor. And the combination, he got 100 units, and ISO Q2, he got 200 units. Units of labor have been taken on O-axis while OY units of capital. IQ represent an output labor of 100 units, whereas IQ2 represent 200 units of output. So this is because at a higher curve, factors of protection are more heavily implied, and either more capital or more labor inputs factor result in a greater level of production. And next, the two ISO product curve never touch, yeah, never cut each other. You see here, uh, as two indifference curve cannot cut each other, two iso product curve cannot cut each other. As you see here, they are cut each other. This is not found in the figure 6. Two iso curve intersect each other point A. Both curve IQ1 and IQ2 represent two level of output, but they intersect each other at point A. Then combination A, if they are intersect, combination A equal to combination B, and combination A equal to combination C. Therefore, B must be equal to C because A equal to B and A equal to C. So you can say B equal to C. But it is observed B and C lies two different iso product curves. Therefore, two curves which represent two levels of output cannot be intersect each other. Curves that intersect are incorrect and produce results that are invalid. As a common factor combination on each of the curves will reveal the same level of output, which is not possible. So, two isoquants never cut each other. Now, next, uh, isoquant needs not to parallel to each other. So, it is so happens because it is so happened because the rate of substitution in different isoquant schedules needs not be necessarily equal. Therefore, isoquant may be parallel, may not be parallel, if not may be parallel. As shown it, we may note that the isoquant IQ1 and IQ2 are parallel, but the isoquant IQ3 and IQ4 are not parallel each other. The rate of technical substitution between factors may have variations, so it not be parallel to each other. Now, next, no ISO can touch either x-axis or y-axis. You can see here if an isocan touches x-axis, it would means the product is being produced with the help of the labor. If it is such that the producer don't use the, it means only one factor is responsible for producing the given level of output without involvement of any other factor. And you are seeing these logical absurdities for OL units of labor along are unable to produce anything because only one factor is not only one factor is responsible for producing the given level of output without using the other factor, and it's not possible. So in any production the producer use both factor. Now I think, I hope you have understood the properties of the ISO quant. Student, hope you understood well what is the properties of ISO quant. Now we discuss about the difference between indifference curve and ISO quant, because indifference curve is used for the consumers and isoquant curve is used for the producer. The main points of the main points of difference between indifference curve and isoquant are explained below. So first of all, isoquant curve expresses the quantity of output. Each curve, as you see here in the different diagram, each curve refers to given quantity of output, while an indifference curve to the quantity of satisfaction. Indifference curve says about the given the quantity of satisfaction, how much satisfaction a consumer get. It is simply tells the combinations on the given indifference curve yield more satisfaction than the combination on a lower indifference curve of production. So, isoquant curve is related to the producer and it says the quantity of the output, and interface curve is related to the consumer's choices. So it is tells about the satisfaction. So isoquant curve represent the combination of the factors, whereas indifference curve represent the combination of the goods. As isoquant curve is related to the producer, so it tells the combination of the factors as labor and capital, and indifference curve is related to the consumer choices, so it tells the combination of the two goods. The isoquant curve gives information regarding the economic and uneconomic reason of production, while indifference curve provides no information regarding an economic and uneconomic reason of consumption. As uh, economic growth is depend on the production level of a country. So it tells us about the economic and uneconomic reason of production, how much a production is increasing in an economy. So and Slope of an isoquant curve is influenced by the technical possibility of substitution between factors of production. It depends on marginal rate of technical substitutions, whereas slopes of indifference curve depend on marginal rate of substitution between two commodities consumed by the consumer. Uh, as I also explained you that the slope of isoquant curve is depend on the marginal rate of technical substitution, while the slope of the indifference curve is depend the marginal rate of substitution. So we can say the slope of isoquant is known as the marginal rate of technical substitution, whereas the slope of indifference curve is known the marginal rate of substitution. So the isoquant shows the firm's predictions function, whereas the indifference curve shows the consumer utility function. The isoquant, the combination of inputs used by the firms to produce a certain output level. On the other hand, the indifference curve shows the combination of the commodities in a bundle that provides the consumer with the same level of satisfaction. And the marginal rate of substitution depicts consumers' willingness to replace a commodity in a commodity bundle with another commodity that provides similar satisfaction. At the same time, the marginal rate of technical substitution show how a firm can replace one input factor with another without changing the output level. Student, hope you understood well what is the isoquant, what is the isoquant curve, what is the isoquant map, the properties of isoquant, and the difference between indifference curve and isoquant. I think you completely understood in this video all the meanings of isoquant. Thank you very much.